Let's look at some titration examples. Example number 1. We're given an order to administer 1,000 milliliters IV with magnesium sulfate 20 grams. We're asked to start with a bolus of 4 grams for 30 minutes, then maintain a continuous infusion at 2 grams per hour. Question 1 asks, what is the flow rate in whole number of milliliters per hour for the bolus order? Our desired metric in this case, again, is milliliters per hour, the rate. We'll begin by looking at the solution. We have 1,000 milliliters for 20 grams. Dame, quit licking. If you can't do that, you gotta go. 3, 2, 1. Let's look at some titration examples. Example number 1. We're given an order to administer Ringer's solution, 1,000 milliliters IV with magnesium sulfate 20 grams. We're asked to start with a bolus of 4 grams for 30 minutes, then maintain a continuous infusion at 2 grams per hour. We're asked first, what is the flow rate for the bolus in terms of the whole number milliliter per hour? Our desired unit then is that rate of milliliters per hour. We'll begin with the solution. We have in this case 1,000 milliliters with 20 grams of magnesium sulfate. The bolus in this case is given to us at a rate of 4 grams every 30 minutes. Since we want our rate to be in hours, we can use a conversion of 60 minutes for every 1 hour to determine the number of grams per hour being administered. When we multiply that by the solution, we should get the number here for the milliliters per hour desired. If we punch this out in the calculator, we should get that 400 milliliters of solution is delivered every hour for the recommended administration. In part 2, we're asked the flow rate of the continuous infusion at the rate 2 grams per hour. And again, we'd like this to be used, or the units to be milliliters per hour. The calculation in this case is fairly simple. Again, we have the same solution, so 1,000 milliliters solution with 20 grams of magnesium sulfate. The rate is given to us here now as 2 grams per hour. Again, canceling out our units, we'll see that we should end up with milliliters per hour. And in this case, the calculation should give us a rate of 100 milliliters for every hour. Let's look at another example. In example 2, we have an order for a drug that's meant to induce labor. Ringlet solution of 1,000 milliliters with pitocin 20 units. Begin a continuous infusion in IV at 1 milliunit per minute. Increase by 1 milliunit per minute every 15 minutes to a maximum of 20 milliunits per minute. What is the flow rate in whole milliliters per hour to deliver the 1 milliunit per minute? The beginning infusion is stated here. Begin a continuous infusion at 1 milliunit per minute. In this example, we start again with 1,000 milliliters for 20 units. What we'd like to end up with here is milliliters per hour, the rate. So how many milliunits are in 1 unit? The first conversion we'll do here gives us that 1 unit is the same as 1,000 milliunits. I use the abbreviation M unit here for space purposes. We also have the rate given to us at 1 milliunit per minute. The last calculation we need involves the conversion factor for minutes to hours. If we take a look at the cancellation of units, the first pair of conversions here will tell me the number of the number of milliliters per milliunit to be infused. The next sort of pair of units we have here will cancel out the millunit to give us milliliters per minute. And then lastly, we can convert our milliliter to minute into milliliters per hour. So we end up with the desired units. Our computation here should give us a rate of 3 milliliters per hour as the rate. In part B, we're asked what is the maximum flow rate in milliliters per hour at which the Titration infusion can be set for the titration as ordered. In this case, we want to again end up with the desired units of milliliters per hour. As before, we have our solution, 1,000 milliliters of solution with the 20 units of Titration. Sorry about that, we're back. Let's keep our coloration the same. So that's 1,000 milliliters with 20 units. We also have, again, the need to convert here. So we have the number of milliunits in that solution. So we'll convert by saying 1 unit is equivalent to 1,000 milliunits. Our particular rate here is given to us as 20 milliunits for every 1 minute. And lastly, the conversion rate from minutes to hours. So 60 minutes for every 1 hour. If we look through, we say the first pair of computations here will tell us the number of milliliters per milliunits in the solution. We multiply that by the infusion rate. As we look at it here with the cancellation, we'll have milliunits per hour. With our milliunits canceling, we'll have then the rate in terms of a volume per time. The calculation in this case should give me a solution here of 60. So 60 milliliters per hour for the rate.